Mining is the second largest industry after agriculture and plays a vital role in the development of civilization. Mining is of metallic ore deposits, for example, ferrous, manganese, chromium, lead, zinc, etc. Non-metallic deposits, for example, petroleum, natural gas, water and coal deposits. Industrial raw material deposits, for example, mica, asbestos, limestone, phosphates, etc. Surfacial loosely held materials of sand, gravel, placer deposits of gold, diamond, cassiterite, etc. Marine deposits, for example, manganese, nodules with 10% copper, nickel, cobalt, and building stones, etc., is a long and complex process. Mining can be divided broadly into surface mining and second, underground mining. First, surface mining is further divided into three types. A. Working loose unconsolidated deposits such as alluvial gravels or mineral sands known as alluvial mining or placer mining. B. Open pit or open cast mining of metalliferous deposits of iron, manganese, magnesite, etc. C. Mining bedded deposits such as coal seams known as strip mining or contour mining. Second, the deep-seated mineral deposits can be worked by underground mining methods. Deep mining is carried out when the mineral deposit is buried 45 to 50 meters below the surface, and in such cases it is not feasible to extract them through open cast mining. Steeply dipping and thin metallic ore bodies are mined by underground mining techniques. In underground mining, there are several equipments and methodologies are used. Before entering into underground mining methods, it is important that one should know the following terms. Let us see one by one. Adit. Adit is a level drive or tunnel made from the hillside to meet the ore body or load occurring inside hills. It opens to the surface only at one end. A normal tunnel passes from one side of the hill to other. A shaft is a vertical or inclined excavation which is either square or rectangular in section line or unlined. Shafts are openings which serve as a means of entry. There are different types of shafts such as vertical shafts, auxiliary shafts, incline shafts, hanging wall or roof. The country rock occurring above the vein or ore body or seam is known as hanging wall. In coal mining, it is called roof. Drive or drift. It is an horizontal tunnel parallel to the strike of the lode or vein, but can be located in the country rock either on the footwall side of the lode or on a hanging wall side of the lode. Stone drift. In coal mining, an inclined tunnel driven through barren rock to connect the working is an upper seam with those in the lower seam or vice versa is called a stone drift. Level. It is a tunnel in the ore body or vein which follows the strike. In coal mining, it is termed level gallery. Crosscut. In mining unstratified deposits, the term crosscut is used to describe a tunnel or drive which leads from the shaft or level and passes through the country rock in order to intersect the lode. Raise. When from a level in the lode or ore body an excavation is made upward in the lode to meet the level above the excavation, it is called a raise. Winze. A tunnel is made downwards from a level in the lode to meet the lower level. The excavation is known as a winze. Ore bin. Ore bin is an excavation lined with masonry or concrete constructions of special design for storing ore minerals from a mine. Ore bins are located either at the main shaft bottom or at the top. Chute. It is a lip or a small channel shaped projection at the bottom of the ore storage bin. It enables the broken ore to be directly loaded into tubs, mine cars, etc. Ore pass. Ore pass is used to describe lined concrete portions of raises or winze through the ore waste filling is dropped. Stope is an underground excavation made for removing or winning the ore. Excavations are made either during the exploratory or developmental stage. It can be classified as follows: excavations lying outside the mineral deposit, excavations made in the ore body. Excavations lying outside the ore body can be grouped as follows. First, parallel to the strike, that is, footwall and hanging wall levels or drives. Second, parallel to the dip, shafts are used in footwall or hanging wall. Third, across the dip, cross-cut vertical shafts, adits, drifts or coal mining. Excavations first, parallel to strike, that is level drives, that is in the lode, sublevels, stopes and chutes, level galleries for coal mining. Second, parallel to the dip, raise or winze, inclined shafts, dip or rise galleries in coal mining. Third, across the strike and away from the dip direction. This includes cross-cut within the coal seam and cross-cut winze raise, especially in metal mining. Underground mining systems consist of working that may be naturally supported or artificially supported or may be allowed to collapse as part of a caving method depending on their location in strong to weak ore and wall rock. The principal methods of underground mining are as follows. Stopes with naturally supported openings. This is subdivided further as follows. First, open stoping, gophering, breast stoping, open underhand stoping, open overhand stoping. Second, sublevel open stoping. Third, long hole stoping. Fourth, room and pillar mining. B. Stopes artificially supported openings. It has been further divided as follows. First, a square set method or stoping. Second, cut and fill stoping. Third, rill stoping. Fourth, shrinkage stoping. C. Caving methods. Caving methods have been further divided into first, top slicing. Second, block caving. Third, sublevel cavings. First, open stoping. Open stoping can only be used in hard rocks and in strong ores. The ore is mined and no support is provided for the wall rocks or for the backs. Stope dimensions may be whole of the ore body is small or an arbitrary division of a much larger block. A hole in the ground of 30 meters into 120 meter plan and 60 meter high could be considered typical. If rocks are softer, the open stopes may be kept down to 20 meter width. The open stoping can be further divided as follows. Gophering. The term is applied to small sized, irregular and unsystematic underground workings. It may just comprise drifts or other openings which follow the ore chute or vein. This has been employed by the ancient miners of our country with great skill. For example, Rajasthan and Bihar copper mines. B. Breast stoping. It is a mining method in which the working face is vertical with a maximum height of about 3 to 5 meters. The stope advances horizontally and it is employed in horizontal or low dipping ore bodies up to 5 to 7 meter thick. It is a cheaper method specially suited for the extraction of low grade ores. Open underhand stoping. Underhand stoping is best suited to narrow steeply dipping veins with strong walls and where the ore requires no sorting. This method has been practiced in the Kolar gold mines at shallower depths. When an excavation started downwards, that is, down dip from a level, such a method is known as underhand stoping. Open overhand stoping. In this method, stoping is started from a raise in the lower level and progress upwards to the next higher level. The broken ore falls down due to gravity and the working face is freed for miners. Second, sub-level open stoping. It can be applied to deposits of uniform grade. The ore should be strong enough to permit working benches. This method is best suited to steeply dipping ore bodies, but it can be modified to suit low dipping veins also, where the dips are low, 12 to 30 degrees, and ore body is wide enough. The following procedure is adapted. First, a raise is driven on the hanging walls. Second, a raise is driven in the footwall. Third, sublevels are made in pairs, one above the other at regular intervals near the footwall and also just below the hanging wall. These are known as hanging sublevels and foot sublevels. Fourth, a slice is made by working both the hanging wall raise and footwall raise. Fifth, the broken ore falls into the footwall raise, into the grizzly or tough screen, and into the chute, and finally into the haulage levels. Third, long hole open stoping. It is of less labor intensive variety of sublevel stoping in which larger blocks of relatively uniform ore can be taken by fan drilling and massive blasting from locations in the sublevels. The drill hole fan pattern must be carefully designed and controlled so that unbroken boulders of ore will not be left and so that wall rock will not be blasted loose and allowed to dilute the ore. The broken ore is extracted from draw points on a lower level. All the drilling, loading of explosives and blasting operations are carried out by miners in the upper level. Long hole stoping methods are used in large mines including Mount Isa and Broken Hill, Australia. Room and pillar mining. This method is used in coal seams and also account for 60% of metalliferous mineral deposits from underground mines. The method is well suited to gently dipping and relatively uniform buried deposits, providing the deposits are not too deep or the rock too weak for pillars to support the overlying strata. The limiting depth in coal mines is in the order of 200 to 300 meters. The room and pillar method is low cost method where rock bolts or roof bolts rather than timbers can be used for temporary roof support. Room and pillar width range from 5 to 20 meters. This method is used in the Michigan copper mine and also in Mississippi Valley lead zinc miners and North America for potash and salt mines.
Then coming
Stopes artificially supported. First, a square set stoping or a square set timbering. This method is used where the ore body and walls are weak due to the presence of fractures and falls. In this method, it is noticed that the timber is fitted to form skeletal cubes which appear in the vertical direction as well as in the horizontal direction. The sets are fitted in position after the extraction of the ore. Only 2 floors are opened at one time and the waste is run into the stope through a raise from the level above and distributed. Inclined square sets are used in mining horizontal floor pillars. The ore is removed from the stope and replaced by waste. The stope is started from a raise in the center of the pillar. 4 rows of sets are mined across the full width of the pillar. Then 2 rows of sets are mined in the floor before filling is run into the stope. In this way, the desired stope is established, a new cut is started at the bottom and timbering is placed before the filling is run in. Usually, while side of the stope is filled, the other side is mined. Cut and fill methods of stoping or filled stopes. In this method, the stope is quickly supported by packing or by running in waste, etc. The material of the ore must be strong and walls may be weaker for this method. Several modifications of this method are employed in different conditions. Steep dips are very advantageous to this method. The ore is loaded into mine cars by gravity, but scrapers may also be employed. As waste filling is let into the stope, the chutes are raised upwards by adding additional sets of timber. The waste required for filling is obtained by first blasting the walls where the wall rock is strong, second by driving cross cuts into the wall, third by obtaining from the surface comprising mill tailing, waste or sand, etc. Rill stopes. In this method, the overhand stope is developed in such a manner that the back has stepped appearance. This method is designed to first utilize waste filling of stopes through chutes and second for filling the stope with waste by gravity. A rill stope can be started also as a V cut in which raises are made at suitable intervals. Rill stopes are commonly used to various extents in particularly all metal mine whenever conditions are favorable. Shrinkage stopes. In this method of mining, overhand stopes are developed and the broken ore is not removed from the stope but utilized to support the stope. Soon after each blast, the broken ore fills up a considerable part of the stope and the stope appears to shrink or become smaller in size. This method is used in steeply dipping loads with strong walls. Narrow veins can be completely extracted, but pillars may be necessary for preventing collapses. This method was practiced in most metal mines when the conditions are favorable. For example, KGF. The caving methods can be done by three important methods and are first, top slicing, second, block caving, third, sublevel caving. Top slicing method. This method can be used where the wide veins or massive ore bodies are worked. The ore is mined in horizontal floors comprising slices. The slices are made in the descending order. When each slice is completed, the roof is allowed to cave in before the adjacent slice taken up. Mining is started from the hanging and foot walls and the last slice has to be removed is near the raise. Second, block caving. Block caving is the ultimate development in the caving methods of mining. Block caving may be used in low-grade ore supported pillars are used. The blocked caves can be 200 feet to 250 feet long, from 100 feet to 125 feet high and can be extended to the full width of the ore body. Drifts can be run from the cross cut to the boundary of the block and the ore drawn in at the ends of the drifts and shoveled into cars. This method is adopted in Ohio copper mine. Sublevel caving. This method can be used where the ore body is wide and comprised soft or loose materials. In this method of mining, levels are drawn and cross cuts are made between hanging wall and front wall so as to form level pillars. The development of sublevels is mainly carried out through rays driven upwards from the levels. The timber is used to top of the sublevels, also caves. The purpose of ventilation may be considered to be threefold: to provide a copious supply of oxygen at the working places, second, to remove any harmful gases from the mine, and third, to maintain body temperature of workers. The ventilation arrangements are made to draw air from the surface and to circulate in the underground. Ventilation may be affected in various ways. Natural ventilation. It is most common in small underground workings. The density of air varies with temperature. The temperature inside the mine is higher than that of the atmosphere outside. Dual is the mine has two shafts, one at the higher level than the other side. Second, Furnace ventilation. It is one of the shaft air is heated by means of a furnace. A convection current is set up in the shaft and air from the other parts of the mine is drawn in by ascending column of hot air. Fan ventilation. It is invariably adopted and can be of the induced type or forced type. Induced or exhaust type is more common. Fans used in underground mines are first booster fans, second auxiliary fans. Advantages. Underground mining can go as deep as the development permits excavations to take place. If there is a shaft with headgear, then mining can take place until the depth. If it is accessed by horizontal adits, it can mine until the lowest adit upwards. If it is accessed by decline, the development and mining can continue so long as economic exploitation is possible. Unlike an open pit, it is not dependent on stripping ratios, which means that deep mining of narrow geological structures becomes practical only by use of underground mining. The opportunity to use old mined out stopes as a repository for waste rock blasted in order access further new stopes. Such a process is known as backfilling old workings and helps stabilize the ground, reduces the cost of haulage and helps avoid falls of ground or rock bursts. Disadvantages. Pillars need to be left in place to safeguard the safety and structure of the haulages and drives. These pillars often contain valuable ore that has to be left in situ. Mining in an underground environment is often inefficient with economically valuable material inevitably occasionally being left in the stope roof or floor or side walls, depending on the geometry of the ore body. Underground mining is not suited to the exploitation of a low-grade, wide ore body composed of disseminated mineralization, where volume of production rather than the focus on avoiding dilution within a narrow vein system is the most important factor. Fatalities do occur in open pits, but there are more possibilities for fatal accidents to occur in underground mines. Contrary to what another answer stated, mining these days is quite a safe industry with stringent safety procedures in place. Conclusion. The mining industry exists in a very competitive environment. The only way to survive in a long term is to ensure that each ton of ore mined leaves a profit. After all, cost factors are deducted. In order to get a good and profitable mineral, either it can be metallic or non-metallic deposits. The underground mining is best suited since there is a greater chance of land reclamation. Thank you.